This is example number 2 of chapter 13. So we have a block of mass 10 kilograms that is suggested to a force of 500 newtons. The spring stiffness is 500 newtons over meters, and at S equals 0, so we have S right here, equals 0, the spring is unstretched. So actually the spring is not doing any force, so we always have to put our coordinate system, X and Y, right? So, and we are being asked to find the acceleration when the block has moved S equals 0.5. So we can imagine that S equals 0.5 is right here, so S equals 0 is right here, and S equals 5 is right here. So we have our block right here, and our spring now is compressed. We need to apply our equations of motion, right? Force is equals mass to acceleration, and in this case, we will only have acceleration in the X direction. To do so, to find the acceleration, we will have to draw our free body diagram and our kinetic diagram, right? So the free body diagram of our block in position, let's call that position A, and position B. At position B, my free body diagram will be the weight. I can never forget the weight. The weight is equals 10 kilograms times the gravity. And then I have my normal force, which I don't know where it's located. And then I have a force applied to my block, which is 500 newtons. And I know this angle, which is 3/4. And then I have the spring. Since I'm moving and compressing the spring, the important part here is to put the force of the spring in the correct direction. So the spring wants to go back to the unstretched position. So the spring is pushing me back, the block, in that direction to go back to the initial position. So it's very important to have the spring force correctly. So, and this is a spring force. How much is that spring force? Is K times what I have stretched or compressed the spring. In this case, the spring is unstretched in the 0 position, in this S equals 0, so I stretch the spring 0.5. So it will be, the K is equals to 500. So, and this, what I compress the spring is 0.5. So I know that force as well. So if we want to put the unknowns in my free body diagram, actually I have only the normal force as an unknown, but the body doesn't move in that direction. So now I do my kinetic diagram, and my kinetic diagram is only my force. Actually, I will draw my acceleration in this direction, but I could have my block deaccelerating. That would depend in the magnitude of the force compared to the magnitude of that spring. So that acceleration could be actually positive or negative. I will draw it positive, and if I get a negative value, it means that this is deaccelerating. But since I don't know if it's deaccelerating or accelerating, I will put it as an unknown and my arrow in the positive direction. So I apply add all my forces in X, and that will be equals to my force in X. This is in X direction, right? I do not have any acceleration in the Y direction. So I have the external forces are from my free body diagram, which is this external force that is 500 newtons. So I have 500 newtons times the cosine of that angle, which will be 4/5, minus the force of my spring, which is 500 times 0.5, equals, I don't have any other force in X direction, equals to my mass, which is a block of 10 kilograms, times AX. So that's my equation, and I just solve for A, And if you solve for A in that equation, it gives you an answer of 15 meters over second squared. So I got a positive value, a magnitude of 15 and a positive value. It means that that force is still accelerating my block. And well, obviously, eventually, that spring will be strong enough to stop the block from moving, but in this position, the block is still accelerating in that direction.